Hi everyone, welcome to Math Help Sessions. My name is Sathana, and in today's video we're going to be looking at finding the answer to why is there an exclamation mark in math? And the answer to that is factorials. So in today's video we're going to be looking at what is a factorial and how to solve different questions which involve factorials. Let's get started by looking at the basic structure of what factorials look like. So a factorial is a notation which is used to shorten a mathematical operation, and this operation is multiplying or finding the product of the number n and all of the whole numbers which precede it. So the general structure of what n factorial is this. N factorial can be rewritten as all the numbers which precede it, so n times n minus 1 times n minus 2 times n minus 3 times all of the numbers in between up to times 2 and times 1. So this may not make a total amount of sense right now, but once we go through a few worked examples, I'm hoping that you will start to get a better understanding of what it is. In short, it is the multiplication of the number n and all of the whole numbers before it. So you're multiplying all of them together. Let's look into a first example and let's try to solve that. So our first example is, what is 5 factorial? So anytime you see this exclamation mark, you can when you're saying it, you can say it as factorial. So what is 5 factorial equal to? So in this example and all of the other examples, we'll be trying to solve factorials by hand because you can't solve factorials by just putting it into your calculator. But in order to understand what a factorial is, we're going to be doing these by hand. So in order to solve what 5 factorial is, we have to recall that n factorial is the product of n times n minus 1 times n minus 2 all the way to times 2 times 1. But what exactly does this mean? So what you're doing is you're multiplying n times the number that is 1 less than n times 2 less than n, and so on and so forth. So if we want to apply this for 5 factorial, we substitute n equals to 5. So if we were to do that, we get 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And what that means is, so n is equal to 5 and you're multiplying by n minus 1. So what is 5 minus 1? That's 4. So you're multiplying by 4 here. And then you're multiplying by n minus 2. So 5 minus 2 is 3, which is what you're multiplying by here. Multiplied by all the numbers in between. And then there's no numbers in between because you go straight to times 2 and times 1. So 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Now, if we want to further solve this and get like a final whole number, that number would be multiplying all these numbers together. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, and 120 times 1 is 120. So 5 factorial is equal to 120. Now, let's look at a slightly more complex example. So example number 2 is 11 factorial divided by 7 factorial. So don't get freaked out because it looks a little bit more complicated. We can break this down step by step in order to easily solve this question. So first of all, let's just look at the numerator. So what is 11 factorial? 11 factorial is the product of 11 times all the numbers which come before it. So 11 times 10 times 9 times 8 times all the way to times 2 times 1. And then let's just look at the denominator. So the denominator is 7 factorial. So what is 7 factorial? 7 factorial is 7 times 6 times 5 times all the way to times 3 times 2 times 1. So if we put that together, 11 factorial over 7 factorial looks like this. 11 times 10 times 9 times all the way to times 2 times 1, and 7 times 6 times 5 times all the way to times 2 times 1. Now, if we want to simplify this, what we can do is we can find factors which are in the numerator and in the denominator, which are the same, which you can then divide out in order to simplify this fraction before we multiply everything together. So if we see here, we can see that there's a 7 here and a 7 here. So because there's one in the numerator, one in the denominator, we can cancel or divide both of those out. Next, there's a 6 here and a 6 here, so we can divide both of those out. There's a 5 here and a 5 here, so let's divide those out too. A 4 here and a 4 here, and a 3 here and a 3 here, and a 2 here and a 2 here, and anything multiplied by 1 is that number itself, so we can also cross out these two ones. Finally, what we're left with is 11 times 10 times 9 times 8, and we know we're done because there's no more factors in the denominator which we can divide out, so this is the most simplified we can get. And what we're left with is 11 times 10 times 9 times 8. And if we want to simplify this even more, we multiply these four numbers together, which gets us 7,920. So again, what we did was we expanded out the numerator and the denominator, we canceled out all of the common factors, and then we multiplied all of the factors in the numerator which were left, and that would give us our final answer. Now let's look at a slightly more complex example. So example number 3 is, what is 15 factorial divided by 10 factorial divided by 4 factorial? So again, this may look a little bit more complicated, and don't worry, because we're going to go through this step by step. So let's just look at the numerator. What is the numerator? It's 15 factorial. So how do we simplify 15 factorial? We can expand it and rewrite it as 15 times 14 times 13 times 12 times all the way to times 2 times 1. And what's in the denominator? Well, because there's 10 factorial and there's a 4 factorial, we can say that we're multiplying these two together. So first, let's look at the 10 factorial. 10 factorial is 10 times 9 times 8 times all the way to times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So let's look at that all together in one big fraction. It would look like this. And yes, there's a lot of factors, but we can simplify this using similar techniques to how we simplified example 2. So in example 2, we saw that the first factorial will always have all of the factors in the numerator and denominator. Because this number is greater than this number, all of the factors in this 10 factorial will be found in 15 factorial. So let's just say that we can divide out all of this 10 times 9 times 8 times 7 all the way numerator and the denominator. So let's go ahead and do that. So now what we're left with in the denominator is 4 times 3 times 2 times 1. And we know that we'll be done simplifying if we divide out all of these factors. So let's try to find some combinations of factors which we can use to divide out these numbers. So first off, we have 4 times 3. Well, 4 times 3 is 12. And if we look in the numerator, we do have a 12 here. So what we can do is we can divide this 12 by this 4 and this 3, and then that will get rid of these two numbers in our denominator. So let's go ahead and do that. Next, what we have is this 2. However, if we look on this numerator, there's no individual 2 which we can divide out by. But if we examine here, there is a 14. 14 is the combination of multiplying 7 by 2. So if we divide this 14 by 2 and we divide this denominator by 2, the 2 in the denominator will get divided out, and in the numerator we'll have a 7 left. So let's do that. And finally, there's just a 1, but anything divided by 1 is just that number, so we don't have to worry about 1. So in the numerator, what we're left with is 15 times 7 times 13 times 11. So let's just simplify this and bring it to the next step. So it's equal to 15 times 7 times 13 times 11. And if we multiply that together, we get 15,015. So that's how we would simplify 15 factorial divided by 10 factorial divided by 4 factorial into 15,015. We cross out all of the common factors in the numerator and denominator and simplify with that. Now let's get on to a slightly different looking example, example number 4. So example number 4 is n plus 1 factorial divided by n factorial. You might be a little bit confused because we were working with whole numbers before, and now we're going back to this n business. What is n? So we have to recall that from the very beginning of the video, all throughout, I've been mentioning that n factorial is equal to n times n minus 1 times n minus 2 all the way to times 2 times 1. And we've been seeing how this works because every time we substitute another value for n, the multiplication will just be that times the one number before it times one number before it all the way to times 2 times 1. So we know that this kind of works. I mean, I hope that you're starting to understand what n factorial truly means. So again, let's break it down like we did in every other example. Let's just look at the numerator. So what would n plus 1 factorial be? So n plus 1 factorial, we can rewrite that as n plus 1 times n minus 1 times n minus 2 all the way to times 2 times 1. Let's look at the denominator. Well, n factorial, which we already have here, is n times n minus 1 times n minus 2 all the way to times 2 times 1. So let's just write that out in an expanded form in our fraction form. So this is what it looks like. We have n plus 1 times n minus 1 all the way to times 2 times 1. And in our denominator, we have n times n minus 1 times n minus 2 all the way to times 2 and times 1. So similar to our previous example, how we found that in the denominator, all of the factors in the denominator, if there's only one factor, can be canceled out or divided out by all the factors in the numerator. We can see that this n times n minus 1 times n minus 2 all the way to here is the same as this n times n minus 1 times n minus 2 all the way to times 2 and times 1. So we can rewrite this as n factorial, because n factorial is n times n minus 1 and so forth. And we have that here and we have that here. So let's go ahead and rewrite these two as n factorial first. So if we do that, we get n plus 1 times n factorial divided by n factorial. Now we have the same factor in the numerator. In the denominator, we have an n factorial here and we have an n factorial here. So let's go ahead and divide those two out. And if we do that, we're left with n plus 1. And that's it. And I hope this makes a little bit of sense if you think about it from a logical perspective. So if we say that n is equal to 5, then we can rewrite this as 6 factorial divided by 5 factorial. And then in the numerator, it would be 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, it would be 5 times 4 times 3 times 2 times 1. And we have a 5 times 4 times 3 times 2 times 1, or 5 factorial in both the numerator and the denominator. So if we cross those out or divide those out, you're just left with 6, which is n plus 1. So I hope this makes a little bit more sense. And if you're not totally, sure of how to solve more of these variable style questions and you want to see me go through a whole bunch of variable style factorial questions, put it in the comment section below and I will definitely create a video with more variable style work questions. Let's move on to another example, and this one is more of a special case. So our special case, so what is 0 factorial? That's what we're going to do today. What is 0 factorial? Well, you might think, okay, what numbers multiply to make 0? And it's just 0, right? But 0 factorial does not equal 0. Actually, 0 factorial is equal to 1. This may confuse you a little bit because, how can 0 factorial equal to 1? It doesn't make sense. Well, let's go through a short proof for why this does work, and hopefully after the end of this proof, it will make a little bit of sense of why 0 factorial is equal to 1. Let's go through that proof. So, at the very beginning, we always have to recall, which I've been saying throughout this video, that n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 all the way times 2 times 1. So, what we can do is we can rewrite this n factorial as n times n minus 1 factorial. And you might be thinking, how does that work? Well, what is n minus 1 factorial? N minus 1 factorial is n minus 1 times n minus 2 times n minus 3 all the way to times 2 times 1 because it's n times all the numbers before. So in this case, if n is equal to n minus 1, it will be n minus 1 times n minus 2 all the way to times 2 times 1. Well, if we look back at our original equation here, we have n minus 1 times n minus 2 times n minus 3 all the way to times 2 times 1. So we have that right here. So we can rewrite this portion as just n minus 1 factorial. And obviously we're still left with this n, so we can rewrite n factorial as n times n minus 1 factorial. And this also makes a little bit of sense if you look at it how I explained the previous example. If we think that n is equal to 6 factorial and we want to rewrite 6 factorial, we can rewrite it as 6 times 5 factorial, right? So I hope this makes a little bit of sense of why we can rewrite it like this. So if we want to solve and figure out what 0 factorial is, let us substitute n equals 1 into this equation. And you may be wondering, why are we picking 1? Because we're trying to solve for 0 factorial. But let us do this, and hopefully it will make a little bit more sense to you after some time. So let's just substitute 1 into this equation. If we do that, n factorial, so 1 factorial will equal to n, so 1 times n minus 1. So 1 minus 1 factorial. So let's simplify this a little bit more. So 1 minus 1 is 0. So 1 factorial is equal to 1 times 0 factorial. So we know that anything times 1 is equal to that number itself. And 1 factorial, well, what is 1 factorial? It's just 1 because it's 1 times all the numbers before it up to 1, but there's no other numbers, so it's just equal to 1. So if we do that, we can rewrite this as 0 factorial here is just equal to 1, which is, what I mentioned here, 0 factorial is equal to 1. So this is the proof for 0 factorial equals 1. This is a proof that I think is easy to understand, but there's many different ways to prove this. This is just one method of proving it. And this is a special case for 0. Every other whole number will get you the multiplication of that number times all the numbers before it. And this is just a special case because 0 is a special number. So those are all of our worked examples, and let's go into a generalization. So to recap this video, Factorials are the product of the number n and all of the whole numbers which precede it, and it's written in the form n factorial can be expanded as n times n minus 1 times n minus 2 times n minus 3 all the way to times 2 and times 1. And in this video, the examples we looked at were, multiplying just a simple factorial and trying to expand it, doing a little bit of division, doing a little bit more complex division, working with some variables and factorials, and finally our special case of 0 factorial. Now, factorials is a concept that you can learn as an elementary school student because it just involves multiplying numbers and understandings of fractions. However, it is important to understand factorials because in high school, there are certain concepts which will require you to have a basic understanding of factorials, and it will involve the use of using variable factorials and solving questions like that. So concepts like permutations and combinatorics will require you to have that knowledge of how to solve factorials but using variables. So it's important that as an elementary school student, you understand factorials so you can use it in high school. And as a high school student, it's important that you have a good understanding of how to use this if you want to be able to further solve more complex questions in all of the other strands in which factorials applies to. And as I mentioned before, if you would like me to create a separate video which further explains how to do multiple different worked examples of just factorials that have variables in them, put it in the comments and I will definitely create a video for you guys. And I think that's it. So thank you so much for watching. I hope that by watching this video, you're able to learn more about factorials, how to use them, and how to solve different questions that involve factorials using numbers, using variables, and also ones that involve using 0 factorial, which was our special case. If you have any questions, put them in the comment section below, and I will try to answer them. And as always, thank you so much for watching, and I hope to see you in a future video. Bye!